Hello everyone, our topic today is electrical resistivity and conductivity. By the end of the lesson, you will understand what resistivity means, the factors affecting resistance, and why the unit of conductivity is called the Siemens. Electrical resistivity. Electrical resistivity is a fundamental property of a material that describes how much the material opposes the flow of electric current through it. Most metals are good conductors of electricity, hence they have low resistivity. Examples include copper, aluminum, and silver. Other materials strongly oppose the flow of electric current. These are known as insulators, and they have high resistivity. Examples include rubber, glass, plastic, and wood. It is important to note that resistivity depends only on the type of material, not on the length or thickness of the wire. Resistivity is represented by the Greek letter ρ, written as factors affecting the resistance of a wire at constant temperature. When resistors are being made in the laboratory, short, thick wires are used to make low resistance, and long, thin wires are used to make high resistance. This is because resistance depends on two main factors. One, length of the wire. If the length of a wire is double, its resistance also doubles. If the length is increased 5 times, the resistance becomes 5 times its original value. This is similar to connecting several equal resistors in series. So resistance is directly proportional to the length of the wire. R is directly proportional to L. 2. Cross-sectional area of the wire. A thick wire can be thought of as many thin wires connected in parallel. When the cross-sectional area of a wire increases, its resistance decreases. For example, if the area of the wire is double, resistance becomes half its original value. So resistance is inversely proportional to the cross-sectional area of the wire. Combining these two results, we get R is directly proportional to L over A. R is equal to rho L over A, where R is the resistance of the wire in ohms, L is the length of the wire in meters, A is the cross-sectional area in square meter. Rho is a constant called the resistivity of the material. The SI unit of resistivity is the ohm meter, written as electrical conductivity. Electrical conductivity is a measure of how easily a material allows electric current to flow through it at a given temperature. Materials with high conductivity conduct electricity very well, while materials with low conductivity do not. Conductivity is simply the reciprocal of resistivity. It is represented by the Greek letter sigma, written as mathematically, sigma is equal to 1 over rho. The SI unit of electrical conductivity is the Siemens per meter, written as Sm raised to minus 1. The unit of conductivity is named after Ernst Weymann von Siemens, a famous German electrical engineer and inventor. Siemens made major contributions to the development of electrical engineering, telecommunications, and power systems. In his honor, the unit Siemens was named after him to represent electrical conductivity and conductance. In summary, resistivity tells us how strongly a material opposes electric current. Conductivity tells us how easily a material conducts electric current. Conductivity is the reciprocal of resistivity. The unit of conductivity is named after Siemens, a German electrical engineer. Example: a 2 ohm resistant coil is to be made using a wire of resistivity 42 times 10 raised to power minus 8 ohm meter. If the wire has a diameter of 0.42 millimeter, find the length of the wire to be used. Use 22 over 7 for pi. The given values. Resistance R is equal to 2 ohm. Resistivity rho is equal to 42 times 10 raised to power minus 8 ohm meter. Diameter of the wire D is equal to 0.42 millimeter. We must convert millimeters to meters. 0.42 millimeter is equal to 0.42 times 10 raised to power minus 3 meters. We use the formula R is equal to rho L over A. Rearranging to make L the subject, L is equal to RA over rho. The wire is circular in cross section. So A is equal to pi r square. Let's find the radius. R is equal to d over 2, equal to 0.42 times 10 raised to power minus 3 divided by 2. R is equal to 0.21 times 10 raised to power minus 3 meters. Now substitute into the area formula. A is equal to 22 over 7 times 0.21 times 10 raised to power minus 3 in bracket all squared. A is equal to 22 over 7 times 0.0441 times 10 raised to power minus 6. A is equal to 0.1386 times 10 raised to power minus 6. A is equal to 1.386 times 10 raised to power minus 7 meters square. Now substitute all values into the formula. L is equal to RA over rho. L is equal to 2 times 1.386 times 10 raised to power minus 7 divided by 42 times 10 raised to power minus 8. Simplifying, 2 times 1.386 is equal to 2.772. 2.772 divided by 42 is equal to 0.066. Now let's handle the powers of 10. 10 raised to power minus 7 divided by 10 raised to power minus 8 will give us 10 raised to power 1. So L is equal to 0.066 times 10. L is equal to 0.66 meters. This question clearly shows how resistivity depends on material, resistance depends on dimension, and why careful unit conversion is very important. If this explanation helped you, please like, share, and subscribe to encourage us. In the next lesson, we'll be looking at how to measure resistance using various methods. Thanks for watching and keep studying smart.